Hello, and welcome to Eyes on Success, a weekly program covering a wide variety of topics of interest to people with vision loss. I'm Nancy Torpey.
And I'm Pete Torpey.
Our goal is to achieve what has been regarded as the Holy Braille concept, which is to be able to display a tactile graphic and standard size Braille on the same tactile surface.
And wouldn't that be wonderful? A graphical Braille display. People have been thinking about that for a long time.
We'll talk with Greg Stilson and William Freeman from the American Printing House about the new technology behind the combined text and graphics display that they are working on developing, as well as new formatting standards for those displays. But first, for our tip of the week. This week's tip comes from William Freeman and Greg Stilson.
So my tip would be that you should keep your devices up to date. You know, whether that's your Braille display or your audiobook reader or your phone or your tablet. I know, especially like with your phone or your tablet, it can be a little scary because they do break things sometimes. But I do think it's a good idea to stay up to date, to follow that news, to check out the release notes, and just stay on top of it because you can see what those companies are focusing on, and then you can write them and let them know whether you agree or disagree with the directions they're going, and you can try out all these new features. It really is helpful to stay involved and stay in touch with these companies, you know, APH, Apple, all of us. And let us know what you're thinking of the things that we're trying to do.
And the other thing is, sometimes with these devices, whether it's software or hardware, if you get too much behind, the next update is just a bigger hassle to deal with if you're lucky.
It can be a lot to learn, and suddenly they've got new menu items and things you don't know about, and maybe they changed the hotkeys, and suddenly you'll be a bit lost. Whereas if you stay up to date, it'll be gradual.
And when you look at the larger organizations, the Apples, the Googles, the Microsofts, right, they're pushing out security updates as well. Unfortunately, we live in a world where hackers are always trying to do some new thing, and the big companies are trying to defend against that, right? So making sure that you always have the latest security patches and things like that, it benefits you as the user.
Support for Eyes on Success is provided by
aphconnectcenter.org, empowering people toward independence and success by providing blogs, information, and resources for individuals of all ages who are blind or visually impaired. Information and referral line are at 1-800-232-5463.
You are listening to Eyes on Success. Success, 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 success.
Let's start by meeting Greg and William and learning about what their roles are at APH.
Well, we have two guests with us today, and I thought, Greg, you could start by introducing yourself.
I am Greg Stilson. I'm the head of Global Technology Innovation here at the American Printing House for the Blind. I've been working in the assistive technology space for the better part of 17 years and joined APH in 2020. And I lead a team of software engineers, quality assurance analysts, and technical product managers, really to sort of take a product or a technology product from ideation to the final product.
And William, can you introduce yourself?
Sure, yeah, thanks. Really happy to be here. It's William Freeman, and I've been at APH for 10 years. I am the Tactile Technology Product Manager at APH. I started as a Braille transcriber. Then I did accessibility testing as a QA, and now I work with the Braille displays, embossers, all of our tactile tech.
Most of our listeners and most of your clients have visual impairments. Do you?
I am sighted.
And I am not. I always say, though, William can read Braille almost as well as a blind person. So he's pretty incredible at being able to read Braille. Although you read it with your eyes, right, William?
Yeah, I read it with my eyes, but I also, coming from accessibility testing, I use screen readers and magnifiers and all the accessible tech. And so I do have a lot of experience in that area.
I think it always works better when you have developers working on products that they actually use.
Absolutely.
Eyes on Success is made possible in part by our corporate partners. Underwriting pairs the impact of targeted marketing with the integrity of community goodwill.
Learn more by sending an email to hosts@eyesonsuccess.net.
This week's focus topic is the new technology behind the combined text and graphics Braille display being worked on at American Printing House, as well as novel formatting standards for such displays.
Today, we want to talk about a new initiative that you folks are working on at APH. It's about a new type of refreshable Braille display. Can you give us an overview, and then we can get into some of the details?
Absolutely. So back in, I want to say 2014, when Larry Skutkan was leading the team, they started a project called the Graffiti Project. And the goal with that was to be able to display graphics on a tactile display.
We actually did a show about the graffiti display with Ken Perry from APH and Venkatesh Chari from Orbit Research.
Yep, Ken is sort of our guru on all things tactile display, and he's got a hand in this project as well. And being APH, a lot of what we do is research based, right? And so a lot of the projects that we start may not end up making it to market, but we use a lot of those learnings to ultimately build something better. That project unfortunately didn't see the light of day from a production perspective, but we learned a ton about how blind and low vision folks interact with dynamic tactile graphics. It's not something that people have been exposed to a lot. And so we learned, for example, that a blind person didn't by nature understand what it meant to use a pinch and zoom gesture, for example.
Interesting.
That is totally natural. My 5-year-old just naturally does that on an iPad, right? So, those type of things, the idea of panning or scrolling around a tactile graphic, because when we're presented a tactile graphic, it's on a fixed piece of paper, right? So, when we bring forth this idea of zooming in on a graphic and then zooming around, one of the things William told me very early on is that when you have graphics and you zoom in too far, you end up zooming into blank space, and the blind user doesn't understand where they are in the graphic anymore. So they end up losing track of where they are and need to zoom all the way out and then start over. And so, those are just a couple examples of some of the learnings that we learned. Well, ultimately, and I know that many organizations have tried to do this. There's been a lot of academic efforts in this space. Our goal is to achieve what has been regarded as the Holy Braille concept, which is to be able to display a tactile graphic and standard size Braille on the same tactile surface, with the goal here at APH of essentially replicating a textbook. We are the largest producer of tactile textbooks in the United States. A tactile textbook is extremely expensive. It takes a very long time to produce, a long time to ship to the student. Our dream and the sort of our North Star on this project is to develop a technology that will essentially become a tactile e-reader for a blind student in the classroom. Ultimately, we ended up selecting to essentially create a joint venture with Humanware, who also has been working with Dot Incorporated out of South Korea on a brand new Braille cell technology. And this is, many of you may have heard of the Dot Watch. This is not the same Braille cell that you may have felt on the Dot Watch. This is a Braille cell that, as a blind person myself, it feels very natural, like a Braille dot. So that's sort of where this vision of the project started.
That raises a very interesting question. As a sighted person myself, if I want to interact with a graphic item on a screen, I look at it in order to absorb the information. But then if I want to do anything to it, I touch it. Well, as a blind person, if you want to absorb the information, you have to touch it. And then if you want to do anything to it, you touch it. I assume you've solved this problem.
Here's the thing. We've solved it on paper, but on paper is very different than putting these things in front of people. This is something that, when you develop products, you build out a product specification, you build out use cases, you build out user personas, and we've done all of that. The problem is, until we actually have a working prototype with all of the sensors and technology in place, we can't actually observe how somebody would put all of these pieces into action. We've gone around and we've demonstrated what I would call proof of concepts, which are basically what the graphics are going to feel like. We've simulated experiences of somebody panning around, but we haven't been able to actually simulate what it will be like if somebody really does pan or scroll around a tactile graphic. And so we're shooting for alpha units to be coming here in the coming months. And I jokingly say to my wife that the world tour starts then at that stage, and we start traveling around. We've got a list a mile long of schools and organizations that are more than happy to host us and host user groups for this type of thing. I'm really excited to get this actually out in the hands of people and watching how they're interacting with it and seeing really what we've missed, because I expect we have missed a lot.
And development is always like that. As you go along, you learn, and the design will get modified. You iterate.
Absolutely.
And on that question of using touch controls, I think what's really interesting is, when you're touching a tactile graphic, you actually have to stop touching it in order to use touch controls. Because even though you're touching the screen, you're not really touching the graphic anymore. You're changing how you're interacting. And that's how people get lost. They can't tell how much they're moving to the left or the right. They can't tell how much they're zooming in or out. And so I think that's where the problems really stem from.
What we're trying to do is sort of compensate for this in the event that somebody does get lost in a graphic or things like that. We're creating a concept where you're going to be able to essentially select a quadrant where it'll move you to the upper right, upper left, or bottom right, and essentially center you in those locations. So you at least have a general understanding of where, if the graphic is zoomed in, where you've kind of routed yourself. So you don't have to zoom all the way out. You kind of get yourself to a familiar location. But once again, that's on paper. We don't know if that's actually going to work in practice. In the simulations that we've done, people seem to get it. But, until you actually put this in front of somebody in a live graphic situation, that's something that we're going to learn a lot about.
So it sounds like working on the Graffiti platform, you learned a lot about what you wanted to do for the next iteration. And in particular, the technology behind the display itself is very different than most refreshable Braille displays, which rely on piezoelectric elements. Can you describe a little bit about the new technology and how it's different?
So it's based off of a magnet that gets charged, and it basically spins a pin into an up or down position. And when it's up, that pin is essentially locked in place. And so these electromagnetic kind of pulses will basically tell that pin what to do, because it only has a 1 or a 0. The difference is that, and this was one of those, with every project, there are compromises that have to be made for the greater good of the project. And one of the compromises we made that we believe is worth it is that the Graffiti had 5 levels of dot height that it could be at, and that's one of the limitations of this technology. We felt that the benefit of being able to produce standard Braille on graphics or with graphics greatly outweighed the need to have multi-height dots, but the dot is either standard Braille height or it's down. That's it.
And I guess one of the advantages of this technology is that you can get a higher packing density of the dots. Is that right?
Correct. Yes. Yeah. We can fit more dots on the display. But I'll tell you, we learned a lot from Graffiti, and one of the things that we really learned from Graffiti was that building technology for technology's sake, it never works. There needs to be a whole infrastructure to support the technology, and so one of the concepts that we sort of live by at APH is this concept of the Holy Braille Highway. And what that means is the idea, and Craig Metter, our president, kind of put it this way, and I really like it, is he's like, you can build the fanciest car you ever want, but if you have no roads to drive it on, what use is it going to be at that stage? And so what we're doing is essentially working with organizations around the world to build in a number of pieces that are going to support this technology, training being one of them. This is going to be something that is entirely new to people. It's going to be entirely new to teachers. Teachers have never taught something like this before. And of course, the blind users as well, who are going to be using this product. We're also going to be building in distribution networks around the world, localization around the world, Braille translation. But most importantly, it's one of the biggest pieces that William has been a massive asset on for us is we're building an entirely new dynamic Braille standard that we're referring to as the eBRF, and we're working with partners around the world to support that effort as well, because one of the things we recognized very early in this project is, yes, we could put a BRF file on this device, and that's the files that books are produced in today, but there is absolutely no dynamic navigation at all from a BRF. And yes, you could put a DAISY text file on this, but when you do that, then you lose all the Braille formatting. So we learned really early on that there's just no file type that is going to be dynamic enough to support what this thing can do and allow somebody to be more efficient. And so that is a big piece of the Holy Braille Highway that we've been hard at work on.
So to extend your analogy a little bit, the on-ramp of this highway is that you need to have access to the information in any of these graphical elements that you're trying to display. So you talk about textbooks, and I was a physics major, so most of the figures in my textbooks all the way through graduate school had an image, whether it was a graph or a photograph, and then writing. But you don't want to do a graphical display of the writing. You want to convert that into Braille that won't grow when the user pans in. How do you deal with that?
One of the things that we're looking at is potentially building that concept into the alt text of the image itself. So the alt text is sort of the hidden text that's behind an image that can provide a description of it. And so using those type of tags, and that's something that one of the things that is a big piece of the eBRF is it is a marked up Braille file, essentially. And so you get a lot of the same benefits that you'd get from XHTML and CSS and things like that. It can even go beyond that because the device is also going to have audio, so we can provide audio tags to graphics. There are significantly more opportunities to enhance a graphic than say what you're talking about, where it says see figure B, where it gives some description in figure B, right? So I think there's a ton of potential there that we could do. But our goal is either to keep the Braille on the screen when the graphic's there, almost like a split screen kind of situation, or adding the alt text into the graphic, either to be spoken out loud to you or potentially to be read in a different way.
So you were talking about the new technology on which these displays were made and based on the dot technology. I actually have a dot watch. We did an interview with them several years ago, and I was reviewing the watch. And I noticed two things. That first of all, on the watches, they have a protective layer that has to be replaced once in a while. And then also, you couldn't touch the display as it was refreshing. And I'm wondering how those impact this new device that you're working on?
It's a great question. No, I appreciate you bringing that up. It presents one of the larger user experience things that we're solving. Due to the electromagnetic technology that's built into this, you are correct that you cannot have your finger on a cell when it's refreshing. However, in software, what we're doing, because we're able to tell the state of individual cells or pins, we're able to essentially recognize when something has not refreshed correctly and choose to then refresh that specific cell when available.
So this is sort of like error correction in computers. You can compensate.
Exactly. You got it. And then that sort of film membrane that goes over the top, that will be on the dynamic tactile display surface. We know that the peanut butter and jelly test with children is an important one. And so one of the ways that HumanWare and Dot really impressed us was at the end of their demonstration of the technology, they took a can of Coca-Cola and they dumped it on a pad of 300 Braille cells.
Oh my gosh.
And all of our hearts stopped at that point. We were just thinking, oh my gosh, like that this is going to totally backfire. And they just wiped it off with a damp cloth, and it was all good. And from at least the user testing that we've done so far, folks have been, really excited about the way that it feels. It does not inhibit the way that you read or you interpret a tactile graphic.
Do you expect authors and publishers to include all of this, alt text and additional information? Or is that going to be part of the process of converting it to a tactile version?
So while the device will be able to take just a regular image and try to turn that into a tactile graphic, those will never be as good as an actual tactile graphic made by a tactile graphic artist. Tactile literacy is a really hard concept to teach. And so giving someone just, here's what we made, we just put this together, some lines and some textures, good luck, and expecting them to succeed is I don't think, fair. Whereas a tactile graphic artist, they're following all these rules and all these considerations that the reader doesn't even have to think about, but that still help them understand what it is they're looking at. So combining that with technology, I think is the best solution to provide the graphics folks need.
And Nancy, just to be clear, what we're trying to do here is not take a book directly from a publisher and throw it on this device. If we do that, it's going to fail. Braille transcribers are the experts at producing properly formatted Braille in ways that blind people can understand it. There's decisions that they make that, as a blind user, I don't even know that they made a decision there. It just, what I'm reading makes sense. This is where the eBRF can come into play, though. What we're picturing is a situation where we're going to still run through the same Braille transcription process, where a book comes from the publisher. It gets run through an initial Braille translation process where it takes all the text and translates it into Braille. We use either Braille Blaster or Duxbury to do that. But then what happens, and William, you know this a lot better than I do, but there's a heck of a lot of adaptation after that first round of Braille translation. Is that right?
Yes, there's a whole lot of considerations that go into Braille. So
what we're shooting for here is you keep the same Braille transcription pipeline that exists today, but we're modifying it to make it more electronic, so that the book is translated electronically. Transcriber is turning it into this eBRF, and then they're clicking a button that basically sends it to the user. So you're shaving a significant amount of time and cost off of the actual production of hard copy Braille. So you're removing the process of embossing, binding, packing, and shipping, and you're still getting perfectly formatted Braille from the Braille transcriber. But in addition, you're also getting tremendous amounts of markup so that the user can navigate by page, by chapter, by unit, by heading. But there's a ton of other benefits that Braille manufacturers, software providers can add in to create some really unique user benefits. Like one of the things that William often tells me is if you don't like a table, let's say in stair-step format, there could be a setting in there that says I want all the tables that show up here to be in list view rather than in stair-step. It basically is a way that you can override the decisions that were made by the transcriber if you like things a certain way.
It's one of those things that I think Braille readers don't think about while they're reading is all the decisions the transcriber made, and that includes the different table types. And the transcriber tries to do the best that they can, but they're not even necessarily a content expert. You have people that are NIMIT certified, NIMIT experts that aren't math experts. They can identify the different pieces of math, but they, if you asked them to do the problem, they wouldn't, be able to. And so they're making all these decisions, and they do their best, and I think they do a very good job, but it should be up to the reader to decide how things are presented to them.
Well, it sounds like an exciting new technology, and there's lots of developments that will still be ongoing and lots of user testing. It'll be interesting to see how this matures and winds up being made into an integrated device that people can use.
Yeah, absolutely. As you said, there's a ton of work left. I would say some of the biggest pieces that have still yet to get done is obviously we feel like we've solved the technology piece. We've got to do that user testing. The big pieces now are the development of the eBRF, the adoption of the eBRF, and finding an organization to carry it forward in the same fashion that the EPUB standard has been carried forward, or the DAISY standard. That has to be brought into an international acceptance place. But we're incredibly excited, and we know that this is something that is desperately needed in the classroom. The last piece that I'll mention is the government advocacy. We are currently working with the federal government. We're advocating with the federal government to enhance our existing federal appropriation or our quota system to basically beef that up to ensure that we can get this in the hands of as many folks as we possibly can, because it will be an expensive device.
Well, we and an awful lot of other people are certainly hoping that you have success with this project. It's very exciting.
Oh, thank you very much. We need all the support we can get, and I am incredibly excited, as I said before, to see it in the hands of folks and watching all the things that we missed at that stage.
You are listening to Eyes on Success. Success, 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 success.
Now for this week's final item, how to learn more about American Printing House, or APH, and their programs, including the development of a combined text and graphics tactile display, and how to contact them.
If people want to find out more about the APH and what is going on there, where would you send them?
So our Facebook page is facebook.com/American Printing House. And then our Twitter is at twitter.com/APH for the blind. And they can also go to aph.org. We have a newsletter that we send out they can sign up for. We've got mailing lists for our different products. So there's a lot of ways they can stay involved and stay in touch with APH.
And if people want to track this project and see how it's going, is there a way they can do that?
There's an email address they can send an interest, and especially if they want to be involved in user testing. One of the things that we're looking to do here in the fall, as I mentioned, we have a list of a lot of organizations that are happy to host us. What we're going to do is set up, I would say, regional testing sites where folks in those regions would be able to come in and get their hands on this device and run through some user experience testing. So if folks are interested, we have an email address that they can send a note of interest to. It's just simply DTD, Dynamic Tactile Device, DTD@aph.org.
And if somebody had a question or a comment, how would they submit that?
If it's about the Dynamic Tactile Device, go ahead and send it to that same email address, dtd@aph.org. If it's a general question, we have a customer service team that is available. They can send an email to cscustomerservice@aph.org, cs@aph.org.
And as usual, you can find all of that contact information and the resources in the show notes associated with this episode at www.eyesonsuccess.net.
That's it for show number 2228. Next week on Eyes on Success, we'll be talking about our listeners' pet peeves. In show number 2223, we featured a variety of our pet peeves that impact how a blind person can navigate in a world primarily designed for and consisting of sighted people. Well, that show elicited lots of responses from our listeners who resonated with what they heard. And next week, we will share some of their stories and their pet peeves.
There were really some great stories we got from our listeners, and we're sure you'll enjoy that. And we hope you'll join us next week.
You've been listening to Eyes on Success, hosted and produced by Nancy Goodman Torpey and Peter Torpey.
You can access the full archive of previous shows, subscribe to the podcast, and much more by going to our website, www.eyesonsuccess.net. If you have questions about anything you've heard on the show or have suggestions for future shows, send an email to hosts@eyesonsuccess.net.
Thank you for listening and have a nice day.